Hello all, welcome back to Quantify. Today we are going to solve a question from NEET 2025 which most of my students asked me to solve. And the reason is this question has got two parts. First part is you need to find the value of A, and second part is you need to find the value of alpha, beta, gamma, delta. And most of the institutes, not most, all of the institutes including Akash, Ellen, Physics Wala, Unacademy, they only provided solution to this part alpha, beta, gamma, delta. But today, for the first time, we are going to find the value of A, which turns out to be minus 1 by 2, I guess. So, by the way, myself, Pawan Dodda, the founder of Quantify, and also I am working as faculty in Doctors Medical Academy, Khammam. So, let's dive into the question. So, the question is as follows: we got a balloon. Let's draw the balloon. And the balloon is made up of material whose surface tension is given as S. Let's write it as S. We got an outlet through which the air is filled in, and also now the air is going to flow out of this balloon through this outlet, and this outlet area is given by A. Now the air density is given as rho, and also the air is moving out of this outlet with a velocity v. They are saying that this velocity v is directly proportional to the radius r to the power of a. Now I need to find the value of this small a, and let's say the radius of this balloon is given as capital R, and now the time taken to reach this radius capital R from R to 0 is t, because as the air moves out of this balloon, the radius should keep decreasing, the balloon keeps shrinking, and one day it reaches to 0. So the radius should turns out to be 0 at one day, and the time taken to reach from capital R to 0 is this time t. This time t is dependent upon the variables such as surface tension, area, and the density, and the initial radius r, as follows. Now we need to figure out the value of A, alpha, beta, gamma, and delta. So let's find the value of A first. See, now if you look carefully, the pressure just outside the outlet is atmospheric pressure, which is P0. Now the pressure inside the balloon is given by, P0 plus 4 into S by R. This is the excess pressure which is inside the balloon. So now if you consider this horizontal surface, now let's apply the Bernoulli's principle. The pressure at this point, just before this, which is P0 plus 4S by R, should be equal to the pressure at this point, which is P0, plus the velocity with which it is coming out. So the kinetic term, which is half rho v square. Since I am considering this as a horizontal line, there is I am also applying just Bernoulli's principle here and here. So there is no potential energy term, which is rho gh. So let's get cancelled. This rho naught gets cancelled on both sides, and we'll be left with let's bring this 2 here. Then we get 8S by R is equal to rho v square, and we get v is equal to square root of 8S by rho R. So that means v is directly proportional to R to the power of minus 1 by 2. Now we are getting this. So this R, A, whatever A we are getting, this A is equal to minus 1 by 2. So this is how we get A is equals to minus 1 by 2. Now this is how we do this part 1. And now let's do part 2, even though it is given by most of the institute, but still let's do it from our side. Now this time t is dependent upon, by the way, now for part 2 we are going to apply the dimensional analysis, but for part 1 we just derived it without using the dimensional analysis. So that's where the most of the students got confused, and it has given a lot of trouble, because first part we are dealing without dimensional analysis, and second part we are dealing with the dimensional analysis. So there are two different approaches in a single question, and definitely this is not at all a NEET question, NEET level question. So let's get back to this second part. T is equals to surface tension. Surface tension is nothing but force per unit length, but force is ml t power minus 2, ml t power minus 2 by L, which is going to be m t power minus 2 power alpha, and area is length square L square power beta and density is mass per unit volume. So m L power minus 3 whole power gamma, and R is L to the power of delta. So now T is equal to, let's bring all light terms at a side, m power alpha, and we got gamma here plus gamma, and also we got T terms aside, which is T power minus 2 alpha, and let's bring all L terms one side, which is L to the power of 2 beta, and minus 3 gamma, and plus delta. Now let's equate the dimensions. Now if you write carefully, there is no m term here, so I should write alpha plus gamma should be equal to 0, which means alpha should be equal to minus gamma. And if you look at the options, A should be minus 1 by 2, so which means these two options are ruled out at the very beginning itself. And alpha should be equal to minus gamma. This is only possible with option C, because here alpha is equal to gamma, not minus gamma. So this should be the answer, but let's check it out. And also second thing is minus 2 alpha is equals to 1, because time power is raised to the 1. So I should be getting alpha is equals to minus 1 by 2. So I should be getting alpha is equals to minus 1 by 2. If alpha is equals to minus 1 by 2, then gamma is automatically 1 by 2. Now let's find this. 2 beta minus 3 gamma plus delta should be equal to 0. And we don't know about the beta, but gamma is given as we don't know about gamma. We got gamma is 1 by 2. Substitute gamma is equals to 1 by 2. And if you substitute beta is equals to minus 1, let's check what we'll get as delta. Substitute beta is equals to minus 1. So minus 2 minus 3 into 1 by 2 plus delta should be equal to 0, which gives delta is equals to 7 by 2, which fits our option 4. See, the most important thing is here you can't get the values of exact values of beta and delta, because the beta and delta, they can have different values too, because here you are getting 3 equations. This is your first equation, you call it as first equation, this is second equation, this is your third equation, and we got 4 variables: alpha, beta, gamma, delta. In mathematics you have this thing, if you have more variables than the more number of equations, then the equation cannot be solved. So it could have infinite number of solutions. Similarly, you can have different values of beta and gamma satisfying these equations, but you will have only one set of alpha and one set of gamma. So this is how we solve this question. I hope this is clear, and we'll see in next video.